this is your say Yuba. Okay, so today we're going to do paper 2, the first paper 2 that we're ever going to do in this on this channel. And we had said we were just doing paper 1s, but then you guys demanded it. You said you wanted paper 2, and so we're doing that. So the first question says state any two differences. Okay, so state any two differences between the structure. Here I'm just underlining the buzzwords. The buzzwords means the key words that are included in the question. That's what I'm underlining. So first key phrase is two differences. Okay, so you're just supposed to state two differences. We might state more, but when you're writing, you're just supposed to highlight two differences only, unless you're not sure about one difference and then you have to add another one. That would be fine. So the structure of an insect pollinated flower and a wind pollinated flower. Okay, these are the two focus groups that we are going to for which the difference we're going to state here. Okay, so here it says structure. There's a reason I underlined this. The main difference between insect pollinated flower and wind pollinated flower are their agents. Okay, for insect pollinated it's the insects, but for wind pollinated it's wind. But then here it says in terms of the structure of the flowers, so you're supposed to reflect that. And so we answer this in terms of certain items. The petals are certainly different. That's what we are going to include. And we're also going to include the pollen also, and we're also going to include the stigma. Okay, so there's three some of the things that we're talking about, but you can also include the stamens. Okay, so there's this four. So insect, pollinated flower on one side, and then wind pollinated flower. Okay, so now we are going to answer it in tabular form. So insect pollinated flower, you could say the petals are light colored. So the reason the petals are light colored here, if you're writing British spelling, you have to put OU here, but then this is the American spelling. So the petals, they are light colored and scented. Okay, it means that they are light colored and then they are perfumed. The reason is we want to attract insects. Okay, so it's if they are bright colors, they can stick around, they can stick out in the ecosystem. Okay, that's the reason. So for wind pollinated flowers, the petals are dull colored, or you can say dull or light. Okay, or light colored, right? And then no scent. There's no perfume. They are not perfumed because it's not necessary. And then the second difference, you can say the stigma in the stamens. The stigma and stamens are small. They're small and hidden. Don't write "and" the way that I'm writing here. You should write "and" hidden. Okay, so let me actually write it the proper way, and hidden. Then here the stigma and stamens are large and protruding. So protruding means sticking out. If you don't want to write any big words, you can say they're sticking out. Okay, that's one difference. So just a recap, what we did was that we cited here, you can do it on a piece of paper. We cited some of the features that we know that are common for insect and wind pollinated flowers. So the petals, the pollen, the stigma, and the stamens. And then we started now to write the differences according to the to the structures, because here it says between the structure. Okay, so these two, they will suffice. But then let's just have one more difference, and then we can continue. So in insect pollinated flowers, the pollen grain, so the pollen grain, you can think of it as the male gametes. Okay, those are the male sex cells. So the pollen grains, they are few and generally big. Okay, then here the pollen grains are small and copious. If you don't want to write copious, you can say so copious simply means that they are in big amounts. Okay, so you can actually write and in big amounts. So these are the differences, the three differences that we have cited here. And here there's no wastage. Okay, in insect pollinated flower, the pollen grains, they're also sticky. They're also sticky, and they also, if you want, you can actually write the pollen grains, they are sticky here for insect pollinated flower. The pollen grains here, they don't need to be sticky, because the agents, they're actually insects or animals. Okay, so here they're sticky. Here they don't need to be, just suppose the agent is wind, so they don't need to be sticky. They just have to be carried in the wind. So they have to be small, they have to be light. Here you can say light. Light means small in terms of the weight. Okay, so those are the three reasons that we're going to cite. And just remember, we are reflecting the structure, we're reflecting on the structure. So that's why we stated some of the things that we are going to curate our differences from. So these are some of the features that you find in flowers. So we said our differences based on these features. State any one condition needed for photosynthesis. Here we're going to state many again, but then just choose one. Okay, so for photosynthesis, you need carbon dioxide. And one way to remember this is to actually just remember the word equation. So carbon dioxide plus water, it gives you what? Glucose plus oxygen. And then there will be sunlight there at the, so you need carbon dioxide, you need water. And three, you need what? You need sunlight. Okay, so carbon dioxide plus water plus sunlight. And four, you need chlorophyll. You don't need to write all those. Okay, just write one or two. If you're not sure, just write two. If you're sure, just write one. So this fifth one, you only include it if they say 5 conditions for photosynthesis to take place. Then you can include this one, but then it's not very necessary always. So it's what? Minerals. Spellings. Minerals and nutrients. There are some minerals and nutrients that support photosynthesis, so you can include them. So just remember that you're supposed to state one. And if they say state, it means just write. You don't need to explain. Okay, just write. State means just write. State again means just write, don't explain. So let's move over to question 2. What does it say? It says during photosynthesis, carbon dioxide and X react to produce glucose and oxygen. So name the reactant X. So let me actually write the word equation. So it's carbon dioxide plus what? Plus water. And then here we'll be having an arrow. This will be sunlight. Sunlight is the energy from the sun that fuels this relation. So we get glucose plus oxygen. If you're doing chemistry, then you're supposed to know how to write this in terms of a balanced a balanced chemical equation. So carbon dioxide will be CO2, this one will be H2O, this one will be is it C6H12O6, I think. then this one will be O2. Then you're supposed to balance it. You're supposed to know if you're doing chemistry. If you're not doing chemistry, just remember the word equation and just remember the formulas for the reactants. So reactant X here, carbon dioxide and water. So reactant X is what? Water. Okay. So water here, that's what you're supposed to write. You don't need to do this. This one you can do it on a piece of paper. You can include it if you want in your exam, but then just remember that the reactant X is water. You can say it explicitly so that the marker doesn't have to look for that answer. So describe what happens to the glucose after its production. So here there's one controversial answer, part of this answer that I'm going to explain. Some of the glucose is used in respiration. So there's this controversy. Sometimes people think that since flowers, they produce glucose, they actually breathe in carbon dioxide in some sense, but then this is not it. Flowers are aerobes. They actually rely on oxygen to make their energy for the cell. So for the cell processes, metabolism, remember they have cells. These cells need fuel. That fuel comes from glucose and oxygen. Okay, so it's actually the reverse of the process that will be happening. This is photosynthesis. It's a side project. A plant is just capable of doing these things, but during the night, a plant actually exclusively just converts glucose and oxygen into carbon dioxide and water. So some of the glucose is used in respiration. And then the excess is stored as starch. So one other common question is, why do plants store the excess glucose as starch? Just because starch is insoluble. So it means it doesn't dissolve in water. So that's why it's called a macromolecule. So let's move to the next question. Let me erase this first. And the next question says, state any two differences between sexual and asexual reproduction. So we're going to use our table again. So sexual and asexual. Sexual. So A simply means the prefix A simply means that opposite of sexual, that's asexual. Okay, so the first difference is that in sexual reproduction we have, so you say offspring as, okay, let's start with the basic one. Offspring, there's nothing like offsprings, it's offspring. Even the plural is offspring, is genetically different than the parents. Okay, so here offspring is identical to the parent. Okay, so offspring is genetically different. Here offspring is genetically identical. You can say genetically identical to the parent. Okay, that brings us to a more basic difference between sexual and asexual reproduction. Okay, which is offspring has two parents. Okay, so here offspring has one parent. If you're having a hard time seeing my handwriting, you just tell me, okay, we'll find someone who can take care of the spot, because on my handwriting I know that it's not that good. So if you're having any problems, just comment in the section, and in the comment section just leave a comment and say, hey Mr. Yuba, stick to math, and then I'll do exactly that. But then if you are not having any trouble following my explanations, then that's good, you can continue. So the next one is that sexual reproduction involves two gametes. Okay, so two gametes. Gametes means sexual cells, or sex cells rather, not sexual cells. Sex cells. Two gametes fuse together, right, in sexual reproduction. In asexual, the agent can be, there's something called binary fission. Spellings, Jesus. It can be binary fission. You look this up, okay? It can be fragmentation. Look this up. This is your homework. What is binary fission? What is fragmentation? Or it can be budding. I'll explain to you budding because most of you already know. So budding is when you have a plant and then it develops another plant, sort of, from its side. So it can be a tree, and then it develops another tree, coming from itself. You can actually take those buds and then transplant them, and then you'd still get a tree. But then basically in asexual, they're genetically identical. There's no genetic variation. In sexual, there is a genetic variation. So because the offspring here would be two parents, the male and the sex cells and the female sex cells, there will be some fusing that happens. So that fusing, it gives an offspring which mimics the genetic material of the two parents, but then it's different than either of them. So another one, hey, they really like this thing of distinguishing stuff. So passive and active immunity. Okay, so passive immunity, you don't require any previous exposure. Okay, for you to develop passive immunity, you don't require no previous exposure. Okay, active immunity, it means you're actually infected now. So active immunity, it means following previous exposure. Okay, so the next difference is that passive immunity takes effect immediately. And then when I give examples of passive immunity, you understand why all these things that we're talking about, they actually make sense. So it takes effect immediately. This one checks days or weeks. Okay, to effect, or to take effect. Okay, so what other differences do you have? This one does not last long. Okay, this one can last for a lifetime. Okay, so this one can last for a lifetime. So this one is supposed to read lifetime. And so this one passive, it means from outside, so you actually get it from outside. And active, it means that you have to get infected, and then your memory cells will a part of your body immune system will identify the pathogen, and then it will curate an antibody for that. And then the memory cells, they will have the memory of whatever infected you to begin with. That's why it lasts for a long time. So this one takes time because the body will be investigating. That's when you'll be feverish. So when you're feverish now, your body will be investigating. It means whenever a machine is heating up, sometimes there's a malfunction, and then until it's the malfunction is taken care of, to keep on heating. So you see that in the human body, that effect, it's fever. So when you have a fever, it means your body is taking care of it, or at least trying to do that. So yeah, so that's it. So this is delayed immunity for active, but then once it takes effect, now it actually just go all in. And another difference is for passive immunity, you get it from outside. So it can be breast milk, or it can be the placenta. Through the placenta, you can get passive immunity, and it doesn't take long. It's only for that time. But then for active immunity now, there are like several things that can give rise to it. So there is generally there is creation of antibodies in the body. Okay, so let's move to the next part. Next part says methane is an alkane. Okay, so this one is alkane. It's different than alkene. Okay, you should know this. So we'll understand later on why this difference is essential. But then name any two elements found in methane. So methane, it's a hydrocarbon. Hydrocarbon, it means any compound that only has hydrogen and oxygen, and hydrogen and carbon. Okay, so hydrogen and carbon. If it contains hydrogen, carbon, and oxygen, then it's not a hydrocarbon. Okay, so methane contains hydrogen and carbon. State the type of bond formed between the elements described in 1. So here it's covalent bond. And if you're doing chemistry, the reason this is covalent bond is the differences in the electronegativities for hydrogen and for carbon. They are less than, I think it's 1.7. If they are less than 1.7, it means that the bond formed there would be covalent. Okay, if they are more than 0.6 and are less than 1.7, the difference in the electronegativities, it means that it will be covalent, but then it will be polar. Okay, if they are less than 0.6, it means that the difference, if it's less than 0.6, it means it's covalent and it's polar. Polar compounds, they are symmetric, so you can draw a line of symmetry. Non-polar elements, they are not symmetric. It means that one element will be drawing the electrons to itself more than the other. Thereby, there is asymmetric distribution of the electron cloud. Anyway, draw the dot and cross diagram to show the bonding in methane. So you actually have to know the formula for methane. The formula is what? CH what? CH4. Okay, this is methane. Methane is CH2, I think. You have to confirm. It's been long since I did chemistry. So what you do is here, this is called the Lewis dot and cross structure. So here the carbon will be the central atom, and then carbon will be having 4. So this 4, we distribute them in this way. Okay, and then the hydrogen now will be having 1, 1, 1, 1, such that we don't need any lone pair. If you're doing chemistry, then this was pretty easy for you. Okay, but then if you're not doing chemistry, carbon is in group 4 of elements, so it means that it has 4 electrons in its outermost shell, and these 4 electrons, you can put them there. They need to be shared. For carbon to get its octet state, it means for it to be stable, it actually needs 8 electrons. So that's why it's helping it's helping hydrogen to attain, because hydrogen actually requires 2 electrons only. So that's why here this is a synergy, and everyone is happy. The hydrogen atoms and also the oxygen atoms. Let's quickly move to the next part. What does it say? It says explain why alkenes are more reactive than why alkenes, you see. The functional difference, that's the functional difference that I was telling you about. So the reason alkenes are more reactive is that alkenes have a double bond between their carbon atoms. Okay, so there is at least one double bond in alkenes. There is at least one double bond between their double bonds between the carbon atoms. Okay, so why is this important? Double bonds are chemically attractive to electrophiles. So here, don't let the terms confuse you. So electrophiles here, philios or philos, it simply means liking or loving. Okay, so electron-loving chemical species, they are called electrophiles. If you love cartoons too much, we say you are a tunophile. You see, so that's the when you see this, it means loving or liking. So electron liking elements, they are attracted to this double bond, because double bond, it means there will be 4 electrons there, so it's very attractive. Okay, so that's why alkenes, they're generally more reactive than alkanes. Let's quickly move to the next question. The next question says, iron is produced in the blast furnace. Write the chemical formula of any 2 raw materials which are fed in the blast furnace. So the chemical formula, you require iron ore first. So here they're saying the buzzword here is chemical formula. You actually need the chemical formula. You don't need to write necessarily the word equation. Okay, so, or the word formula. Here the chemical formula, it's Fe, it's iron 3. Okay, so if it's iron 3, it's Fe2O3. These they swap. The valence for oxygen usually the valence is 2, and then for iron here, for iron ore, one of the ores for iron, the most common one, it's iron 3. Okay, so if you're asked to write instead and not chemical formula, you have to say iron 3 oxide. Okay, but here it says chemical formula, so that's why you write this. And the other one is what? You say coke. Okay, and the other one is what? Calcium carbonate. This one you introduce it to remove impurities. So calcium carbonate, the generic name is what? It's limestone. Okay, put it to remove impurities. So these are your answers. Here I was just giving you, if you say write the any 2 raw materials, then you have to write the chemical names. Don't bother yourself writing the chemical formula. But then here it says write the chemical formula for all these things. That's why we're writing this. So stainless steel is an alloy of iron and 2 other metals. State the 2 other metals. So there is chromium, and there is carbon. Okay. Okay, so stainless steel, it involves chromium and also carbon. Okay, and if it's just steel, it's iron and carbon. If it's stainless, then you have to include chromium here. Let's quickly move to the next part. You say state one property of stainless steel and relate it to its use, to the use of stainless steel. So property, you can say corrosion resistant. Okay, it doesn't corrode. if you don't want, you can say doesn't. Hey, the spellings now, Jesus. You can say doesn't corrode. Okay, it simply means it doesn't rust or rust, right? And then the use now is use it in cooking utensils. You also use it for the same reason. You also use it in industrial processes. Okay, you can say industrial processes, especially where the products or the reactants, they are very corrosive. So you want materials that will have a long lifespan, such that you don't have to replace them. If you are building a plant or something like that for a chemical plant, you want your materials to be as strong as possible. So one of those aspects, it's actually corrosion resistant. So here, that's the property that you state, and then you just say cooking utensils or some industrial processes as well. State one way of protecting iron from rusting other than alloying it. So there's what we call barrier protection. So barrier protection is e.g. painting. It means that we're just putting a barrier between the stuff that makes iron rust and iron itself. So the stuff that makes iron rust, it's moisture and oxygen. Okay, so by painting it, you're now introducing a barrier. So that's one way to go about it. And then there's something called sacrificial protection. Sacrificial protection, e.g. using zinc. Since zinc is more reactive than iron, so you'd expect zinc to react instead of iron, thereby you're protecting iron. So that's it. Let's quickly move to the next part. Next part says, oh, it's question 5. So it says draw the magnetic field lines around the conductor. So the magnetic field lines will definitely be like this, but then we have to ascertain now what direction will they be going. So the magnetic field lines will be like this, right? And here what you do is use the right hand grip rule. Okay, so right hand grip rule. So you just imagine as if you're holding this this conductor here with your right hand. If you're holding it such that your thumb will be pointing here, so your thumb would be pointing here, and then you're holding it, you discover using your right hand, you discover that the other your fingers, they'll be curled this direction here. Just pretend as if you're holding it, and your thumb is like thumbs up because the direction of the current is upwards. You see that your hands will be curling from this direction to this direction like this. So obviously this would be your magnetic field lines. Okay, so use the right hand grip rule. If it's going downwards, then you can do, and then here your grip will be going downwards. What you discover is that your direction of current will be moving in the clockwise direction like this. Not in the clockwise necessarily, but I'm sure you get the sense now. So you use the right hand grip rule. It's hard to illustrate here since there's this limitation, but I'm sure you get the point. So that's it, and yeah, so that's it for the first part. We'll continue from question 6 in the next video. So thanks for watching. Make sure you like, share, and subscribe. And yeah, if you don't like my handwriting, just tell me in the comments section right below, and then I'll find some alternative. I can pre-write some of these answers, and then I can explain them to you if that would be better. But then if you think that that's good enough to go with, I think I'd be happy to as well. So yeah, so thanks for watching. Make sure you like, share, and subscribe. Yuba out.